real fall, and we get to have the leaves change colors, which is nice.
Nice. Yeah.
Sometimes it doesn't, it goes like from summer to like winter, and then it goes back to summer somehow during fall, and then it goes back to winter.
Mm-hmm.
And that is rough. So cool. It is 5 past the hour. Thanks everybody for signing up and attending. And if you're watching this on the recording, thanks for watching the recording. It will be on the YouTube channel. This is for our physics and astronomy sea change project. And I am happy to introduce our first one for the school webinar for the school year with Dr. Emily Alicea-Muñoz. She will be taking it from here. If you have any questions, please feel free to type them in the chat or the Q&A. I will be reading them aloud during the Q&A portion. Thank you, everyone.
All right. Hello, everyone. Thanks for coming. My name is Emily Alicea-Muñoz. I'm a non-tenure track faculty member at the School of Physics in Georgia Tech. And I will be talking to you about what we've done to transform the preparation of our physics TAs. So to give a bit of motivation, it is necessary to prepare TAs for teaching. TAs are essential partners in instruction, especially for large enrollment intro-physics classes, where students can end up spending half of their in-class contact time supervised by TAs. They spend 3 hours a week with the professor in a giant lecture hall, and then they spend 3 hours a week in a lab with 30 other people and a TA. So the TAs have a potential to have a large impact on student learning. But TAs are also novice teachers. Many of them have had zero teaching experience prior to their TA assignment. So it's important to prepare them for teaching. And this is not a new thing. It's not a new request. When I was doing the lit review for my dissertation, I found this quote that appeared in an article in MJ Phys in 1957 that said that in his inaugural oration as first president of Johns Hopkins University in 1876, Daniel Coit Gilman expressed the pious hope that graduate schools would help to develop the teaching ability of future professors. This hope has remained largely unfulfilled to date. And wasn't that a dire thing to read? In fact, before about 1970, there was essentially nothing that I could find on TA preparation. In the 70s, I started finding the first inklings of TA preparation. There were articles published about TA preparation programs that covered logistics for teaching labs, basics of pedagogy, and also had classroom observations. In the 80s, there were the first meta-analysis of GTA preparation research, and there were calls for more systematic research because it seemed everybody just reported on what they did, and that's it. In the 90s, PER began getting bigger, and so we had concept inventories, active learning, and the first long-lasting GTA preparation programs started during the 90s, like, for example, the one at the University of Minnesota. And then from 2000 and beyond, there's been lots and lots and lots and lots of work being done on TA preparation. And the research has shown that TA preparation works. It improves TA's confidence, it improves TA's self-efficacy, it improves their pedagogical content knowledge, and can result in the adoption of learner-centered strategies. STEM TAs in particular benefit from this discipline-specific preparation where they can develop the pedagogical content knowledge. And it's been also shown that having teaching experience improves grad students' methodological research skills. And during training, it's important to make sure that you go over things like logistics of classroom management and grading. TAs need help with that. And also TAs need the opportunity to practice and receive feedback before and during teaching. But also, a majority of physics PhDs leave academia. Only about 13% of all physics PhDs go into faculty positions, not faculty positions necessarily, but academic positions. So we're looking at a huge majority of PhDs who never teach again after they've TA'd. So it's important to get the TAs motivated to be good and effective teachers, but if they're never going to teach again, they may not buy into it. So we want the TAs to be motivated and effective teachers, and we also want them to develop transferable professional skills, because even if they never again set foot inside a classroom, things like being able to explain concepts to non-experts, things like managing a small group of people, public speaking, communication, all those things are skills that they develop and improve on while they're teaching that are not necessarily limited to a teaching experience. They can be using that in industry, in government, in wherever their lives take them after the PhD. So what we're looking is for a new perspective on TA preparation. And what I developed for my dissertation was something that I like to call the 3P framework. And it is that to have a comprehensive program for TA preparation that the TAs will find useful and valuable, whether they're teaching or not, we need to have full integration between pedagogy, physics content, and professional development strategies. And the intersections of these 3Ps are also important: the intersection of pedagogy and physics, the intersection of physics and professional development, etc. So for my dissertation, which included the development of this TA preparation program and the program assessment, I had three main research questions. The first question was, what are the elements of a formal TA preparation program that TAs perceive as most useful? Then also, what effect does a formal TA preparation program have on TAs teaching self-efficacy and attitudes about teaching? And also, does a formal TA preparation program have an effect on TA's teaching effectiveness? So with that, I'll give you a little bit of history. Before 2013, in Georgia Tech, TAs would participate in a general TA orientation run by the Center for Teaching and Learning that covered essentially academic policies. And they would meet with the TA supervisors to let them know this is what you're teaching and this is what you're going to do before the semester. And then during the semester, they met weekly with the supervisor to set up the lab for next week. And there were also some pedagogy seminars that were outsourced. They were taught by someone from the Center for Teaching and Learning, and they were scheduled at 6 o'clock on a Friday afternoon. So we had a lot of grumpy cats among the grad students. There was a disconnect between pedagogy and content. They attended these pedagogy seminars that were at a very inconvenient time and were very generic. And then they had their own lab preparation meetings with the supervisor where you only covered like, okay, next week we're going to do this and this and this, let's set up the equipment. There was no pedagogical reinforcement anywhere in the semester. So lots of grumpy cats, lots of complaining. The TAs had no motivation to be good TAs, and there was apparently no relevance for their professional goals, especially the ones who said, well, I'm going to go into industry and my advisor is going to put me on RA next semester. So why do I care about teaching well this semester? I'm never going to do this again. Since fall 2013, I have been teaching a 1-credit pass-fail course. It has been made a requirement for first-year PhD students who happen to also be first-time TAs. If any first-year PhD students come in with a fellowship or something, then they take the class on their first semester TAing, not when they're first years, because the class requires concurrence with a teaching assignment. The course was developed following the best practices for TA preparation found in the research literature. And every year we go through a process, an iterative processes of we teach the class in the fall, we revise and reflect on what things happened in the fall during the spring, and then in the summer we revise the curriculum to then teach it next fall and repeat every year. The course is currently structured with 3 major parts. There is an orientation, which happens before the semester starts and covers basically 75% of the class. And then the orientation is scheduled in 3-hour sessions on different days. And then there's the follow-up meetings, which are during the full semester, roughly every other week, and they are 50-minute meetings. And then there's also outside of class activities that are classroom observations, workload surveys, and mentoring meetings. And by doing this and revising the content every year, we went from, so 2013, this figure on the left is a Venn diagram of pedagogy, physics, and professional development, the 3P framework, where I mapped all the different topics covered in class into the framework, and I noticed these big empty areas. So the framework allowed me to figure out what was missing and then add to it. And so by 2019, as you can see, there's no gaps. And the total class time between 2013 and 2019 actually didn't increase by much. It started at 17 hours and now it's 20 hours. And the course is a lot more robust and a lot more comprehensive. So you may be wondering, how did we get from the left diagram to the right diagram? And this is kind of a Gantt chart of the topics and the activities in the class mapped into the 3P framework. So as you can see, some things have stayed the entire time, like microteaching, midterm evaluations, active learning, grading. Other things have happened on one single year and then never again. Peer observations, teaching philosophy, leadership. And then others started a bit late, like 2016 or thereabouts, and they have stayed true. They have been successful over the years, like the lab simulation, for example. So let's talk a little bit about those things. So things that have been persistent over the years: microteaching, midterm evaluations, classroom management, active learning, grading, etc., etc., etc. Microteaching is a short teaching practice, which is often the very first time that TAs get to stand in front of a class full of people and teach. The TAs have always thought it was very useful because they get to practice in a safe environment where they can make mistakes and learn before getting in front of their students. And microteaching even worked in fall 2020. Fall 2020 was a semester when everything was remote, and TA preparation had to happen remote as well. And microteaching worked with breakout rooms. So that was neat. Grading has had separate sessions for each of the different grading assignments. And we have had recent issues with this, TAs who are not grading correctly, or who take way too much time grading exams. So for next year, what I'm likely to do is move grading into the orientation so that we can have a 3-hour session on it. but this is part of the revision and improvement of the curriculum. Grading had been working fine as a follow-up meeting for several years, and now it doesn't. So we need to change that to better serve our TAs. Also, Georgia Tech policies is, where we have to talk about FERPA and sexual harassment and academic integrity and those things. And the TAs always complained that this was very boring, very legalese. So then in 2017, I created what I call the okay, not okay game. And I present scenarios and I give the TAs these pieces of paper that say okay in one side and not okay on the other side. And then they have to answer, is it okay or not okay? And then some things are obvious and everybody agrees unanimously, and then other things are not so obvious, and then we have disagreement, and that prompts discussion among the TAs about why is this okay, why is this not okay. And ever since then, the TAs have had a lot of fun with the Georgia Tech policies, and it's a really good way of introducing them to the idea of non-discrimination and the importance of inclusivity in teaching, because it's a game and they have fun with it. They don't feel like they're being preached at, which is what they complained about before. So now they don't complain. So that's good. Other things, the things that started that were done one single year, they were all major disasters for one reason or another. For example, peer observations, I did only 1 year, and the TAs had two very common complaints. One was, I don't feel experienced enough to be giving feedback to my peers. And the other one was, my peers are not experienced enough to be giving me feedback. So I scrapped that. It didn't really work. Experienced TA observations didn't work because of logistics issues. Most of the introductory physics classes are taught by first year TAs. So second years and above were very rare. And we had, 20 people observing one person teaching, and so there wasn't a lot of variety there. So that was a disaster. Teaching philosophy was a disaster also, because the TAs said that particular year all the TAs were convinced that they would go into industry, so they thought writing a teaching philosophy statement was a complete waste of time for them. Excuse me. And so on and so forth. So things didn't work out. Now, there have been other things that started later and have been very successful. For example, classroom observations, for which I did a talk at APT this past summer. Classroom observations have been very, very useful. And they are video recorded. It's opt-in. If the TA doesn't want to be video recorded, they can just be followed around with a clipboard. But by now, I have over 600 gigabytes of classroom observation video. And this is a mountain of data that I'm sitting on that I haven't had time to analyze. But some clips get used in future years for training. Lab simulation is a role play activity, which is similar to microteaching, but in a lab environment. We have the TAs take turns, and some of them act as TAs facilitating a lab while everybody else is a student. And they really, really get into this activity because every year I contact roughly 1/3 of the TAs in secret and tell them that they will be sabotaging the activity. They'll get to be a bad student. They get to be on their phone the entire time instead of working on the lab. They get to claim that they want to do the lab entirely by themselves, not with their lab partner. They get to argue back with the TA. And so the TAs really, really get into it. And they have a lot of fun with this activity. And it essentially turns the activity into a lab worst case scenario And so they feel a lot better when they get to their actual labs and see that they don't have problem students at every table. We also now have mentoring meetings with the older grad students. They happen 3 times during the semester, and they talk about wellness. They talk about picking an advisor, working with an advisor, and they talk about career guidance. Um, and this has been very useful for the grad students. When I was still a grad student, I would attend to these meetings, and now that I'm not a grad student anymore, I make sure to not be there at all, because then it's a safe environment for grad students to just chat and complain and discuss things. And it's good that they get all the first years get the opportunity to get this kind of mentoring. So let's talk about now about the numbers. I've been teaching the class since 2013, every fall semester. In 2013, we had 22 people taking the class. This was the pilot semester. I had not thought of making this into a research project. So a lot of things could have been different that pilot semester, and that's the reason why I started developing the 3P framework for the next year. The data between 2014 and 2018 went into my dissertation research, and the analysis that I will be presenting to you today comes from those 5 years of data. Then we have the data from 2019, 20, and 21, which is currently, the analysis of this is currently ongoing. I'm still working on that and getting a paper ready to submit for this. Very curious in particular about seeing what happens with the 2020 group, because that was the remote semester and everything was different that semester. And then future work is the current semester and beyond. So overall, 220 grad students have taken this class. Roughly a quarter of them have been women, roughly a third of them have been international non-native English speakers. I don't have enough data on ethnicities to give you percentages broken down by year in there, but I can tell you that in these past 10 years that we have had 2 Black graduate students, about 8 Latinos, and everything else everybody else has been white or East Asian or Southeast Asian. And so we don't have enough diversity, unfortunately, to break down percentages by ethnicity in every year. But we're working on that. So to do the assessment, excuse me, I used a mixed methods approach. And I have a ton of assessments and a ton of data from the class, but to do this particular assessment, this particular analysis, I picked only some assessments that would give a broad idea of how effective the class has been. Particularly an entry survey, which the TAs answer before they ever meet me, and a set of pre and post tests that are given on the first day that we meet for class, and then again on the last day that we meet for class. An orientation survey where they evaluate the orientation at the end of the orientation. Then a final survey at the end of the semester. And then we look at the results from student evaluations of teaching, with the appropriate caveats that these have to be taken with a grain of salt. So roughly 60% of our first-time GTAs have no prior teaching experience. The other 40% mostly have experience with tutoring, and some of them have had TA experience as undergrads. Some of our more non-traditional grad students have been K-12 teachers, so they have a lot more teaching experience. during the entry survey, one of the questions that I asked them is to indicate how much they agree with the statement, I consider teaching to be an important part of my professional development as a physicist. And an overwhelming majority of the first-time TAs strongly agree with that statement. There's always one or two outliers who say teaching is completely pointless, but the vast majority consider teaching to be important. Also, first-time TAs, being novice instructors, have a lot of concerns about teaching. They're worried. And I always ask them for their top 3 concerns. And between 2014 and 2018, I was able to gather about 200 and something concerns, and I coded them into 19 categories, which can be seen here. And the majority of first-time TAs are worried about their knowledge of physics. They're worried that they don't know enough physics to teach it, or they don't remember introphysics well enough. They're worried that they're gonna show up to a Physics 1 class and try to teach the students with Lagrangians, and they will lose everybody immediately. TAs are also worried about time management, which is understandable because grad school in physics is not a walk in the park. They're worried about being able to have time to do their homework, to study, to pass their own classes, to start getting involved in research. And on top of that, they have to TA, so they're worried about time management. Also, the majority of non-native English speakers are also worried about language and culture issues. So these are the top 3 concerns from our pool of grad students between 2014 and 2018. The 2020 group included things like teaching online, which there had not been any concerns about that before, but in 2020 they spiked. So be on the lookout for that when I finally publish that paper. At the end of the orientation, the TAs have an orientation survey where it is completely anonymous, and they answer Likert type statements about various class activities that happened during the orientation. And they can also give open-ended comments. So in general, the TAs enjoy the interactive nature of the class. They really enjoy the group activities, the think, pair, shares. They definitely don't want to be lectured at. And they find all the elements of the introduction, of the orientation to be useful. In the orientation survey, I also asked them, how prepared do you feel for your first GTA assignment at Georgia Tech? Which I also asked them in the entry survey before they ever meet me. And so I can do a pre-post assessment of how prepared they feel before they set foot in Georgia Tech and after they took the orientation. And these are the distributions between 2016 and 2018. 2019 and beyond look similar as well. But I don't have a figure for that yet. But essentially, the TAs feel better prepared for teaching after they go through the orientation. This is, I compared the distributions with a Kolmogorov-Smirnov test, and it is very significant, and there's a very large effect size measured by Cohen's d. So the orientation is very, very useful for the TAs. They feel a lot better prepared after they have gone through it. At the end of the semester, I asked them to rate the usefulness of all the class lessons, and the overall top 3 most useful have been microteaching, lab simulation, and teaching physics. Teaching physics is the lesson in which we really dig down into the pedagogical content knowledge needed for teaching physics. Yearly top 3s were a little more nuanced. If you notice here, 2017 Intro and Georgia Tech Policies was the most useful rated, and that was the year that I introduced the okay not okay games. So that told me that I was doing something right. I also developed a measure that I call the utility score. It's just a mean of means. where I check the different activities in the different things in the orientation, the follow-up meetings, the out-of-class activities, and then I check year overall. And so I do this calculation for each year separately, and then also for the course overall. And the course overall has a utility score of 3.58. This is in a 5-point scale. Could be better, but it's not bad. And also the orientation is always rated as the most useful thing in the entire class. And every year the TAs indicate more and more agreement with the fact that the orientation is useful. They find the orientation more and more useful. So that's good. But I need to do something about the follow-up meetings, make them feel more useful for the students. Still in the process of analyzing data from 2019 to 2021. I'm very curious to see how 2020 in particular comes out, but I'm not there yet. Finally, I also have pre-post testing. One of the pre-post assessments that I use is the Approaches to Teaching Inventory, ATI, which is a research validated instrument that has 16 Likert type elements in 2 scales that measure teacher-centered approaches and learner-centered approaches. I do a complete case analysis with the ATI results, pre-post pairs with responses to every item. Students who miss an item, anyone who misses an item, that person gets eliminated from the data set. And then for each student, for each TA, I calculated a teacher-centered mean, a learner-centered mean, and then in the pre-test, and then again in the post-test. And the teacher-centered approaches are basically identical in the pre and in the post. There is no change in teacher-centered approaches. However, there is a change in learner-centered approaches. The distribution goes to the right in the post-test, and comparing the distributions with a Kolmogorov-Smirnov test, it is a statistically significant difference. A paired t-test also shows statistical significance, and the effect size, however, is small. It's with a very low coincidence t, but it's there, and that's what matters. So the TAs do begin to adopt more learner-centered approaches after they go through the class. Before the class and after the class, their learner-centered approaches are different. So that's a good thing. The other pre-post test that I have is something that I call the knowledge quiz. This one is not research validated. It's just a quiz that I have for checking just the TA's understanding of the content that we've covered in class. This quiz has changed wildly year to year, but there have been 12 questions that repeated identically every year. And so for those questions, I did a paired pre-post assessment for matched pairs, and the post test had higher means and medians than the pre-test, except for this one outlier right here. But in general, the TA's pedagogical knowledge increases after going through the TA preparation for 1 semester and teaching for 1 semester. So that's also a good thing. Then after the end of the semester, we look at the student evaluations. Caveat, student evaluations alone cannot measure teaching effectiveness. There's tons of research that goes into how student evaluations of teaching can be biased against women, against non-native speakers, etc. So we always want to take student evaluations with a grain of salt. It's very important to get feedback from the students and to see what the students think, but student evaluations alone cannot be used to represent someone being a good teacher or a bad teacher. And I say this as someone who has really good student evaluations in my classes, but yeah, it cannot be used on its own. So the end of semester student evaluations in Georgia Tech, the evaluation for TAs has 12 items, which are described here in this slide. And after much difficulty, I was able to obtain the data for all the TAs who had a first teaching experience before the class was established. So the data from 2011 and 2012. Data prior to 2011, I just was not able to obtain. And then I also obtained the data for the first 3 years of the class. So TAs who were first years in 2013, 14, and 15. And so now this way I have a pre-intervention and a post-intervention. And I looked at the first fall semester of teaching and the first spring semester of teaching for each of the grad students. And I found that the post-intervention group, the people who went through the TA preparation class, they always rated higher than the pre-intervention group. The majority of these differences are also statistically significant. I also noticed that in the spring semester, for the vast majority of items, the spring semester ratings are higher than the fall semester ratings, which, if you consider that the TAs have more experience by the time they teach their second semester, makes sense. The TAs get highest rated in topics that are familiarity with concepts, respect for students, approachability, and preparedness, and they get the lowest rated in stimulated interest in the subject. I've been curious to see what the professor end of semester evaluations look like for that one particular item as well. But yeah, so participating in the TA preparation leads to higher student evaluations. And so with all this, I can now formulate answers to the research questions. So the question of what elements of a formal TA preparation program do TAs find useful? Microteaching, lab simulation, and teaching physics. TAs appreciate hands-on activities. They like when they get to practice and receive feedback before they get in front of their students. And also TAs are interested in developing that pedagogical content knowledge that they need for teaching. What effect does a formal TA preparation program have on graduate students teaching self-efficacy and attitudes about teaching? Well, TAs absolutely feel better prepared for teaching after participating in the TA orientation. And TAs definitely adopt more learner-centered approaches to teaching after going through the TA preparation class. Then, does a formal TA preparation program have an effect on graduate students' teaching effectiveness? Well, the TAs who participate in the TA preparation program have higher end of semester student evaluations than the TAs who predated the program. If you want to take student evaluations as a proxy for teaching effectiveness, then we can say that there is an indication that TAs who take the class are more effective teachers than TAs who predated the class. But this is, again, it's a proxy and it's not certain. It needs additional variables to be looked at. So our work can have a broader significance because there is no one-size-fits-all approach to TA preparation. What works in Georgia Tech is not necessarily what works in some other institution. Lots of work has been done on TA preparation, focusing mostly on TAs as future faculty. But as we know, a vast majority of PhDs leave academia. So it's important to not ignore the needs of these TAs. So I propose that my 3P framework can provide universal guidance to ensure better professional preparation for graduate students when they're TAs, regardless of what their career goals are. And it doesn't necessarily have to be limited to physics. We can change the physics circle in the Venn diagram for discipline-specific content, which can be chemistry, biology, math, whatever. So to summarize, our Physics TA preparation course successfully integrates pedagogy, physics, and professional development strategies. And the course satisfies the principles for best practices in TA preparation, and is effective at preparing TAs for their teaching roles. The TAs find it useful, the TAs find it valuable, and they do adopt more learner-centered approaches after going through it. And our method of curriculum development, the 3P framework, can provide universal guidance for TA preparation, regardless of what the TA's career goals are in the future post-PhD. I am currently working on a project to investigate TA preparation strategies nationwide. If or someone you know works with TAs, I want to know your name and email address. Please scan this QR code so that I can include you in the contact list for my national survey of TA preparation. It's a project that's been in the works for a couple years, and the hardest part has been finding the contact information for the people that we need to send the survey to. And if you're interested in looking at my other TA preparation materials and research, other talks, other posters, papers, you can scan this other QR code over here, and you'll get to a Dropbox folder that has everything in it. So that's it, and thank you.
Thank you so much. And we have some questions, so feel free to ask questions in the Q&A or the chat. First question, Emily, is somebody has wrote, we are discussing training of graduate students to teach in undergraduate classrooms and labs. In a department with distinct separation between these two programs, including separate program directors and reporting lines, how do you recommend navigating development of a more structured training? Who oversees it? Who would fund it? How do you collaborate with the undergraduate program to ensure the needs of the undergraduate program are being met?
That is a very good question. And I think it's absolutely necessary to have the program coordinators be involved in the development process. We have 3 different flavors of introphysics that we teach in Georgia Tech. One that is called traditional, that uses Randall Knight's book. Another one which is uses the MNI, Matter and Interactions curriculum, and then we also have an IPLS, Introphysics for Living Systems. And all 3 different flavors do different labs, do different recitations, do different assessments that need different grading. And when I was developing the course, I had to make absolutely certain that all the coordinators, all 3 different coordinators were involved so that I could cover everything that their TAs need. So in terms of pedagogical content knowledge, it doesn't matter if a TA is teaching a lab or a problem solving or a traditional or an IPLS, because the pedagogical content knowledge for introphysics is going to be pedagogical content knowledge for introphysics, mechanics or electromagnetism. But things like grading, things like classroom management require the input of the coordinators so that everything can be included. Also, the class, this class is not a substitute for weekly meetings to, for example, set up lab equipment for lab TAs. Those still happen, but at least they can focus only on, we need to prepare the equipment, and this is the type of issues that students tend to have with this lab, as opposed to then also having to discuss pedagogical content knowledge, because we do cover that in the TA preparation class. As for funding, we started with a collaboration with the Center for Teaching and Learning in Georgia Tech. I highly encourage collaborating with your institution's Center for Teaching and Learning. They can be a great resource. And the department chair was very on board with this stuff. So he gave me leave to be able to do this for my TA assignment when I was a grad student and also for my research. And I've been hired as a non-tenure track faculty, and my work focus is the TA preparation in addition to teaching introphysics. So you need to have support from the administration of the department. If they're not on board with it, it's gonna be an uphill ride. I hope that answers the question.
I think it's a tricky question to answer. But I think you gave a great answer. So the next question is, to what degree do you help students explore their teaching in a personal way, both in terms of how they bring their identities and interests into the classroom and how they enter into a teaching community of practice?
So we do this in the microteaching and lab simulation practices. So when we talk about teaching physics, when we go over all the pedagogical content knowledge, we emphasize things like how to interpret student questions. Like, what does it mean when a student says, "Does the ball have gravity?" What do you do when a student comes to you and says, "I don't know how to do this problem"? And we have them work on introphysics problems and explain them to each other. And then in the micro-teaching practice, the only instruction that they are given is, here are a bunch of physics problems, pick one. You don't get a solution until after the activity. You have to solve it yourself. And you are not to stand at the board and solve the problem for people. And this allows the TAs to work in their personality. Some people like to start with jokes, or they start with like a historical perspective. Like someone had a problem of a ballistic pendulum and went on the history of ballistic pendulums and why this problem is important in terms of collisions and energy conservation. We also have TAs who, even though they're not directed to be problem students during micro-teaching, some of them do it on purpose too, to just like tease each other. And it's a good practice because that way they can figure out how to deal with trouble students in a safe environment, where if they get frustrated, then they can express their frustrations safely and not like, blow up at their students. And then during the lab simulation, same thing. The TAs are instructed on what they need to do, but also they have freedom to say how they're going to implement the things that they have to do. So during those practice activities, it's very important to allow the TAs to bring their personalities, bring their identities. And also the fact that they're all together in the class creates a community of practice that didn't exist before. When I was a first-year grad student in Georgia Tech, I could name like 5 people in my class, and we were like 40. But since they're all in it together, they're all in the class together, they automatically get the community of practice like evolves naturally, organically. And it has resulted in a lot of cohort cohesion in the last few years. Hope that answers the question.
And here's another question. Is there any research on the best graduate teaching assistant GTA teaching load? Someone pointed out that their program tends to have quite a few required classes for folks to teach.
I don't know if there's any research specifically on the best teaching load. I know that Ken Heller in Minnesota has mentioned the idea that one TA can handle 5 groups of 3 students. So each TA is in charge of 6 groups of 4 students in their labs. But in terms of hours per week, there hasn't really been anything that focuses specifically on that. In Georgia Tech, our students work 12 to 13 hours per week in their GTA assignment in physics, but I know that in chemistry, they have 20 hours per week. So it varies, and I'm not sure there's any research specifically on that. I'm sorry.
I bet that would be a really interesting question for somebody to pursue, but there's probably some also logistical things that hinder these things. So I had a question. Could you describe some of the really effective micro-teaching activities, like really specific ones?
Microteaching is one activity where at the end of the class, the workshop in which we talk about pedagogical content knowledge, I never mentioned the words pedagogical content knowledge to them, though. I put giant sticky notes all around the classroom with each one with pieces of paper where there's problems on them, and then they all have titles like Gauss's law, friction, etc. And so the last 15 minutes of the class is them getting up and walking around and looking at the problems and picking one. And that's the one that they get to teach when they practice micro-teaching. So in fall 2020, I had to do that with a Google form and a Google spreadsheet, and it was not as fun. The very act of walking around and talking to other people while selecting a problem really helps them, because then they get to compare, like, oh, I'm gonna do this problem because this is easy, or I should do this problem because I haven't seen circuits since my first year as an undergrad, and I'm probably gonna have to teach circuits, so I should practice this. And then during the activity, each TA gets 10 minutes to teach their problem. They are explicitly told they're not supposed to stand at the board and solve the problem for people. They have to involve everybody else in the classroom, and they have to get people to solve the problem as if they were students. And some people do like a guided Q&A. They do something on the board and then they ask like, what's the next step? Other people introduce the problem, then they give everybody else 5 minutes to work on it on their own, and then they get back to the discussion. Other people introduce the problem, do part A, and then say, okay, now you guys work on part B, and then I'll come around and see. And they walk around the classroom and see what people are doing and interact with the students. So the fact that each person has to do this and everybody else is in the room as well, they get to see what other people are doing. And so they not just get practice on their own, but they get practice by watching other people teach. And it's very, very useful for them. And then with the lab simulation, so the lab simulation is primarily an activity for classroom management. Each TA in practice is going to be in charge of 20 or 30 students, and they need to make sure that they pay attention to all of them. So that's primarily what the lab simulation is about. But then when I introduce the secret sabotage, it gets fun. And people need to, so I don't tell the group that there's going to be sabotage, and each person that is assigned to sabotage is sworn to secrecy, so they think that they're the only one. And so then when they're working on facilitating the lab that they're assigned to, they get to the idea is who notices these trouble students, and what do they do about it? Some people don't notice, and some people do, and some people get really carried away with being the trouble student. There was one TA in particular who his instructions were for sabotage: you're going to be clumsy with the equipment, but please try not to break anything, because there's always one clumsy student. And so this TA got really into the fact that he was being clumsy. And the lab computer at the station where he and his other lab partner were at didn't seem to work. And so all the TAs had to move them to another lab station. And then when we debriefed at the end of class and I revealed the saboteurs, this one guy, this one person pipes up and says, "Oh, I also turned off the monitor of the computer and no one noticed that it was the monitor that was off, not that the computer didn't work." So that was great. That was just fantastic.
Yeah, I really love the creativity and these things that are really subtle. So we have time for one last question. Do you focus at all on providing asynchronous or written feedback or assessment to the students, or do you primarily focus on in-person interactions?
So the class primarily focuses on the in-person interactions that the TAs are going to have with the students. When in fall 2020, we emphasized how to facilitate labs and recitation sessions online. But since Georgia Tech has gone back to in-person classes and all our labs have to be in person, the class focuses on in person. But in terms of the class itself, I also all the class materials are available for the TAs to browse through Canvas whenever they want. And I give them feedback on various reflection assignments that they have throughout the semester. And also they have classroom observations, so they get feedback on their observations. But yeah, the TAs are prepare mostly for in-person interactions.
Great. Well, it's top of the hour, so thank you so much for attending this webinar. It has been recorded. We will be uploading it eventually to YouTube, and you will receive an email when it's uploaded. So please feel free to share with whoever you wish. And thank you once again, Emily. And I will be stopping the recording.
Mm-hmm.